This question gives us the equation of an ellipse. X squared over 25 plus y squared over 16 equals 1. And we want to find some information about this. The vertices or vertexes, the endpoints on the minor axis. So once we have those 4 points, that really is enough for us to graph it. So let's do that first. Let's take a look at our equation. X squared over 25 plus y squared over 16 equals 1. Let's find the vertices and let's find the points on the minor axis. So we want to think of this as 5 squared because that will tell me from the center I need to go 5 in the x direction. And think of 16 as 4 squared. So from the center I'm going to go 4 in the y direction equals 1. So relative to our graph, center here is 0, 0. 5 in the x direction would put me here at 5, 0. 5 in the x direction back this way would put me at negative 5, 0. So those are the vertices. The vertices here are 5, 0 and negative 5, 0. And how about the points on the minor axis? We go up 4 and down 4. Up 4 would take us to 0, 4, and down 4 would take us to 0, negative 4. So the points on the minor axis are 0, 4, 0, negative 4. Length of the major axis, well, it's 5 in either direction. So the length of the major axis is 5 plus 5 is 10, and the length of the minor axis is 4 plus 4 is 8. So let's see if we can construct a graph for that. So I'm going to go ahead and take a look at Desmos to do that. So we had our points that we called the vertices, the vertexes, at 5, 0 and at negative 5, 0. Then we had the points on the minor axis, 0, 4, 0, negative 4. So those are 4 points. That's really enough to get a decent picture. You're just going to go ahead and connect those dots in an elliptical shape, and that will be the graph we're working with. So we'll let Desmos do that. Our graph is x squared over 25 plus y squared over 16 equals 1. And we can see what that looks like. Again, your major axis has length 10, 5 plus 5 is 10. Your minor axis has length 8, 4 plus 4 is 8. Now, what else do we need to do here? We need to find the 2 focuses. We've already graphed it, so our last task then is to indeed find the foci. Now, how are we going to do that? Well, we have 25 and we have 16 here. Where are the foci going to live? They will be on the major axis. I'll have a focus somewhere here. I will have a focus somewhere there. The thing to remember is the foci are on the major axis, but they're related to these 2 numbers downstairs. So what I have there then is x squared over 25 plus y squared over 16 equals 1. And the rule that we use for an ellipse is c squared equals a squared minus b squared. So the larger of these 2 numbers minus the smaller of those 2 numbers. And then the c is the distance from the center to the focus. So here I'm going to take c squared is 25 minus 16. So c squared is 9. So c is plus or minus 3. So that tells me from the center, go 3 on the major axis. So the one focus will be at 3, 0, and the other focus will be at negative 3, 0. So let us take a look at that. So we have our graph here. We can put our 2 foci at 3, 0 and at negative 3, 0. So we have our equation, we have our vertices, we have our points on the minor axis, length of the major, length of the minor, and the two focuses. I just want to show you something. The distance from this focus to that point, notice this is 3, this is 4. That distance would be 5. 3, 4, 5 triangle. Similarly, this is from this focus to that point. 3, 4 is also 5. So if you'd add those two distances together, 5 plus 5 is 10. How about this distance from this point to that focus is 2. And from this vertex to that focus is 8. Notice 5 and 3 more, so 5 plus 3 is 8. So the distance from this point, the sum of the distance of the focuses here to here is 2. Here to here is 8. 2 plus 8 is 10. Here to here is 5. Here to here is 5. 5 plus 5 is 10. And that reminds you that the sum of the distances from any point on the ellipse to the foci is constant. That's our definition of an ellipse.